Hello.
Yes, sir, you're audible.
Oh, so thank you very much. I welcome you all on this faculty development program, online faculty development program, on the topic next generation technologies in information and communication. I'm extremely thankful to Dr. Shantanu Modak, HOD Information Technology, Bengal College of Engineering and Technology, and HODs of CSC, Computer Science and Engineering, IML, and CSC Data Science for organizing this faculty development program. Let me tell you, it is very, very important to organize faculty development program under the present circumstances when more and more students are required to be, you know, influenced to come to research from all the engineering institutions, higher institutions. More and more students must come to research. Under these circumstances, FDP plays a very important role, and therefore I'm extremely thankful to Dr. Shantanu Modak and all HODs for organizing program. I'm thankful to all the resource persons. I think 10 number of resource persons are there. They're helping in this program. I'm extremely thankful to them from all corners of India. They have joined, and a huge number of participants have shown their interest in the program. So I sincerely hope this program will be extremely useful for all the participants and help us in the process of improving research in India. Thank you. Welcome you all. All the best to you. Thank you. Thank you, sir.
Thank you, sir, for your inspiring words and guidance. So, good morning, everyone. I'm Aniruddha Ghoshal, a student here at Bengal College of Engineering and Technology, and I feel honored to be the host of today's faculty development program, organized by Entrepreneurship Development Cell and Institute Innovation Cell. It's wonderful to see so many esteemed faculty members and guests gathered here, ready to share ideas and learn together. So, firstly, I'd like to extend a warm welcome on behalf of our college to all of you. This program was designed to help us grow as a community and to exchange knowledge and to develop new skills that will benefit both educators and students alike. I'd like to take this opportunity to thank our respected director, sir, and principal, sir, for the invaluable guidance and support in organizing this event. Without their dedication, this gathering wouldn't be possible. So now it's my pleasure to introduce today's session chair, Saurabh Kumar Hajra Chaudhary, sir, who is also the HOD of AIM. We are honored to have him here to guide us through today's discussion. Moving on to our first session. The topic is Basic Statistics for Machine Learning. And I'm delighted to introduce today's speaker, Dr. Dreamli Sharma from University of Delhi. Dr. Dreamli Sharma is an accomplished statistician, an academic professional specializing in quantile-based statistical modeling and distribution theory and regression analysis. Currently serving at St. Xavier's University, Kolkata, she previously held the position of assistant professor at Adams University from 2018 to 2021. Her academic contribution includes six peer research papers in prestigious journals with significant work on statistical distribution and quantile based modeling. She has been also authored three book chapters focusing on quantile based approaches and machine learning application. As an educator, Dr. Sharma has extensive research experience teaching core statistic subjects including statistical inference, probability theory, R programming, and multivariate analysis. Her leadership capabilities are evidenced by her role as the acting head of the Department of Statistics at St. Xavier's University, Kolkata from July 2022 to June 2023. Throughout her career, she has been actively participated in academic discourse, presenting her research at multiple national and international conferences. Her commitment to continuous professional development is demonstrated through her participation in various workshop and faculty development programs, including specialized courses in statistical methods and institutional values. So please join me in welcoming Dr. Dreamly Sharma as she share her expertise on this topic. Over to you, ma'am.
Thank you. First of all, I would like to thank Dr. Shantanu Modak for giving me this opportunity to present today. So I'll first share my screen with you. Okay, are the slides visible?
Yes, it's visible.
Okay, so as we all know that machine learning stands on the theory of statistics. So without understanding statistics, we cannot proceed with machine learning. Okay, I'll just close my video because it makes my connection slow. So here I am to discuss some basic topics of statistics that are useful in machine learning. As the time is short, definitely I won't be able to go to in depth about this topic. So I'll just try as much as possible to make you understand. And please, any questions are welcome. So first, let us understand why is statistics so much important in machine learning. So statistics helps us understand data. It helps us explore relationships. It helps us and evaluate uncertainty. And based on uncertainty, many machine learning techniques are um, evolved. And also it helps us to prevent overfitting. Sometimes we want a perfect fit. So if sometimes some data may show overfitting, so statistics is the tool that helps us to prevent this as well. So the types of data in statistics may be quantitative or numerical, so which may be again continuous like height weight data, or maybe discrete, which gives us count of variables like number of products, etc. Or it may be qualitative or categorical. So under categorical data also there are two types. It may be either nominal or maybe ordinal. So in nominal, the data do not have any specific order, like it may be the name, it may be the color or the gender. And the ordinal data will be the like the ranking, satisfaction level. We give feedback to some product. So those are ordinal data because these have some specific order. But both of this data do not have any numerical value. The types of statistics may be defined into two different categories: descriptive statistics and inferential statistics. So the descriptive statistics, it deals with data visualization technique like various plots, scatter plot, histogram, box plot, and the descriptive measures as well, like calculating mean, median, standard deviation, moments, skewness, etc. And this inferential statistics, on the other hand, draws on estimating and interpreting and also exploring relationship like regression. So now we will go into the details of these techniques. So for data visualization technique, if we collect the data, then we can first draw some plots. So maybe we can draw some bar plot, or maybe box plot, or maybe histogram or scatter plot based on the type of data. And then we will have some basic idea about the central tendency and the spread and the relationship. Like in case of this scatter plot, we can explore the relationship between the two variables, whether it is linear or non-linear. Then this helps us to proceed to the next step. So the next step will be to measure central tendency and to measure the variance or spread. So there are many measures of central tendency. So central tendency basically provides us an idea where the center of the data lies. So we can calculate mean. The formula for calculating mean is x bar equal to summation fi xi by summation fi. So fi are the frequencies and xi are the observation. So frequencies means how many times each of these xi occur, and so this formula gives us the mean. The median is when we sort the data in a specific order, say ascending or descending order, then the middlemost value so obtained is called median. And this median is very much useful when data is skewed, because for skewed data, mean is a bad choice. So similarly, we have mode, that is the most frequently occurring value in the data set. And for categorical data, mode is the best way out if we compare the three central tendency measures. So apart from these three measures also, there are many, but mostly in machine learning, these three are useful. Measure of spread or variability. So once we know the mean, we want to understand the variability of the data. To calculate the variability, there are many measures. Among these are range. Range gives the difference between the maximum and the minimum value. The variance, it gives the average of squared deviation from the mean. So where these symbols have their usual meaning, as explained in the earlier slide. And when we take the square root of this quantity variance, we get standard deviation, which is very, very useful even in interpreting a given data. So statistics will be incomplete unless we understand the concept of probability. Probability is core to statistics as well as core to machine learning. So of course, I cannot go into much detail, but I'll try to make you understand whatever I can. So probability means uncertainty. Uncertainty means it gives the likelihood of occurring between, so this value, probability value lies between 0 and 1. 0 implies impossible event and 1 implies certain event. So like for example, if an event, say it has a higher likelihood of occurrence, or it is more likely to occur, this event is more likely to occur. Similarly, for example, if we flip a coin, then the probability of getting head is 0.5. So 0.5 means the middlemost value, that is it is equally likely. The probability of getting head and getting a tail is equally likely. Some basic terms in understanding probability are sample space. Sample space means the set of all possible outcomes of an experiment. When we perform an experiment, say rolling a die or flipping a coin, then there are some possible outcomes. Like in case of flipping a coin, the possible outcomes are head and tail. So head and tail will form a set. That set is called sample space. Similarly, when we take a subset of this sample space, then we get something called event. So probability helps us understand useful in machine learning algorithm. So probability is associated with randomness. So whenever randomness is there, probability will come. So there are various types of probability, like theoretical probability. Theoretical probability is based only on theory, like we know how many possible outcomes are there. So based on theoretical observation, we can define a probability, that is called theoretical probability. Empirical probability, on the other hand, is based on experiment. Like we roll a die 100 times or 200 times, and we count how many times we get a head or how many times we get a tail, and accordingly we define probability based on the observation. And the conditional probability is again based on the occurrence of one event given that another event has occurred. Like, for example, probability of raining given that it's cloudy. So, of an event can be again described in terms of distribution. So when we describe the probabilities in distributed over possible values of the random variable, then this is called a probability distribution. Probability distribution can be discrete or it may be continuous. Some common discrete distribution used in machine learning are Bernoulli distribution, the binomial distribution, and also the Poisson distribution. And the continuous distribution in machine learning includes normal distribution and exponential distribution. So let us just have a look on the shape of the curve of this distribution. So the first curve, it gives the standard normal curve, probability curve, and it is a bell-shaped symmetric curve around 0. So the mean of this distribution is 0, and also a probability distribution has higher probability around the middle, because we can also see that the curve is quite dense here, and around the tail it is flattening, so it has less probability around the tail. This is a binomial distribution. Binomial distribution is a discrete distribution, so we will not get a continuous curve like a normal distribution. Rather, we will get a scree plot. This is called a scree plot. So where it to each point we get a probability. Like, for example, around the point 10, we get a probability of say 0.12 and so on. Similarly, the exponential distribution is a skewed distribution, unlike the normal distribution, which was symmetric. So it is very much useful in financial risk management. And another most important distribution is the uniform distribution, because machine learning techniques rely on simulation techniques. So for simulation, uniform distribution is the most basic distribution. Without uniform distribution, simulation is not possible. Now let us understand inferential statistics. So to understand inferential statistics, we must first understand what is meant by population. Now, population is the totality of all individuals, so, or the collection of object. And when we take a part of the population, we get a sample. So sample is a true representation of the population. So in general, we do not know the entire population. We cannot collect the entire population because it is cost efficient and very much time taking as well. Calculating the entire population. So the entire population also has some functions like mean, variance, or we can calculate the skewness, kurtosis of the population units. So this is called a parameter. So what any function of the population unit is called a parameter. And when we calculate the corresponding function for the sample, like sample mean, sample variance, then it is called a statistic. Now, each time when we draw a sample from a population, then the same sample is not obtained. Each time a different sample is obtained. So if different sample is obtained, we get a different function of the sample unit. So we get a different value of sample mean with each draw of the sample. Hence, the statistic is a random quantity. So let us learn more about a statistic. So anything which is random has a probability distribution. So statistics, we understood that it is a random quantity. So it has a probability distribution, and the probability distribution of a statistic is called a sampling distribution, which is shown in the diagram here. So when we talk about sample mean, so sample mean is also a random quantity because it varies from sample to sample. So it has a distribution, and the distribution of the mean will be the sampling distribution of mean. Similarly, the standard deviation of the sampling distribution of a statistic is called the standard error, which is very much important again in machine learning. When a statistic is used to estimate the parameter, then it is called the estimator. This is where the whole concept of statistical inference lies. We collect the data, then we calculate a statistic, say sample mean or sample variance. Then we use this statistic as an estimator of the population quantity because we do not know the population value. Then we try to draw some inferences about the population. So this is called statistical inference. So the basic idea of statistical inference is that population parameters are generally unknown. An estimate of the parameter is obtained from the sample, as I explained, and these are used to draw further conclusion about the unknown population. So this entire process is called statistical inference. So statistical inference again is divided into two parts: parameter estimation and hypothesis testing. So parameter estimation deals with estimating the parameter, like we talked about calculating sample mean and then represent, and this we consider it as estimate of the population mean. So suppose like population distribution, the orange one is the population distribution. Now we draw a sample from this population and obtain the sample mean. So sample mean also will have a distribution. This is called the sampling distribution. Now the mean of this sampling distribution, that is x bar, this is called a point estimate, which is a single value. Now for this sample value, we can calculate a range of values for which the probability is very high to fall in this sampling distribution. So this range of values is called interval estimate, which is an lower limit and an upper limit. So we will learn how to calculate the interval estimate as well. So now let us, once we have calculated about the population, so this technique is called hypothesis testing. And hypothesis means nothing but any statement about the population parameter, about the unknown population parameter. So when we make a statement about the population parameter, which is of no difference, that is an hypothesis of equality, then this is called a null hypothesis. Now, based on this null hypothesis, we proceed with some statistical testing procedure to draw some conclusion. Now, any statement which is complementary to the null hypothesis is called an alternative hypothesis. So this is our null hypothesis. So the complementary hypothesis may be H1 theta not equal to theta 2, that is two-sided alternative, because the first one says that either theta may be greater than theta naught or maybe less than theta naught, and the next two are one-sided alternative because it specifically says theta is greater or less than theta naught. So we test the accuracy of the statement using an appropriate statistic based on the data collected. Then we make the decision based on the sampling distribution. So it is very important to know the sampling distribution of the statistic. And then the sampling distribution is divided into two regions. These are called acceptance region and the rejection region. So let us learn, suppose this is the sampling distribution. So the region where there is higher probability, so higher probability lies in the middle part. So this is our acceptance region. And the rejection region will be the region where the probability is very less. And a value that separates the exception and the rejection region is called the critical value. Also, now let us understand what is meant by level of significance. Now, suppose this is our acceptance region, and we have chosen that the acceptance region has probability 0.95. So probability, 12 probability is always equal to 1. So point probability 95 lies in the acceptance region means 0.05 lies in the rejection region. So the probability of the rejection region is called level of significance. So because this is a two-tail test, rejection region may be either in left tail or in the right tail. So each of these tail region has probability 0.025. So that the total rejection probability is equal to 0.05. Now the p-value. We obtain a value of a statistic. Now we find the probability based on this sampling distribution. We find the probability that the value is more extreme than whatever we have obtained. So this is called a p-value. P-value is also given in many statistical tests, and we just need to draw the interpretation. So rejection region for a one-sided null hypothesis lies in one tail, and the one tail area is equal to alpha, that is 0.05. Basic steps in hypothesis testing is to formulate the hypothesis, collect and analyze the data, and calculate the statistic. Now, based on the statistic, we make a decision by obtaining the p-value or the critical value of the sampling distribution. So we will discuss only one test of significance, that is of significance for single mean. Suppose we want to test the hypothesis that population mean is equal to a hypothetical value, say mu naught. Then the first step is to set up the null hypothesis. H naught mu equal to mu naught. We generally denote mean by mu. So mu naught is the specified value against any of the alternative. When we define the null hypothesis, we must define the alternative hypothesis as well. So two-sided as well as the one-sided alternative. Now the next step is to collect sample. So suppose the random sample is x1, x2, xn of size n from a normal population, based on which we must draw the conclusion. Now first we have a sample. Now we will calculate the descriptive statistics, which are called information obtained from the sample. So we obtain information, the sample mean, sample variance. Now we obtain the standard error of sample mean. Standard error of sample mean is given by this formula. Sigma. Sigma is the square root of variance. Okay. Square root of S square is called sigma. So sigma may or may not be known. Sometimes sigma may be known or may not be known. So the test statistics and its sampling distribution is based on whether sigma is known or unknown. This is the null hypothesis. Let us understand this flowchart. Suppose sigma is known, that is population variance or population standard deviation is known. If it is known, then we proceed with the Z test. Z is equal to x bar minus mu naught by sigma by root n. So in this case, the sampling distribution will be a standard normal distribution. Now, in case sigma is unknown, then we replace sigma with S square, the population, the sample variance. So sigma square is replaced by S square, that is sigma is replaced with S, the sample standard deviation. And the statistic is now given by this. Look at the similarity of both Z and T. Both are very similar. Only sigma is replaced by S here. Now we are to obtain the sampling distribution of T. If n is large, sample size that is small, and small n is large, then the sampling distribution is again standard normal distribution. And if sample size is small, then the sampling distribution is a t distribution with n-1 degrees of freedom. Now, based on the sampling distribution, whatever is the sampling distribution, either normal or t, we draw the conclusion and take a decision. So decision can be taken either based on critical value method or based on p-value method. So critical value means the value, this is available in statistical tables or even statistical software, and the p-value method also is available in statistical table as well as statistical software. So we compare with the value. If the if the statistic exceeds the critical value, then we reject the null hypothesis, and also we reject the null hypothesis if the p-value is very small, so smaller than 0.05. So we can then obtain the confidence interval or the confidence estimate of the population mean. So confidence estimate of the population mean is given by this populated by t distribution and small s. Let us see an example. Suppose a claim is made that the average number of days spent on vacation is more than or equal to 5 days. Hypothesized value is of the population mean is 5 days. Based on a sample of 16 people whose mean came out to be 9 days and variance 3 days. So the sample size is 16 and the sample mean is 9, sample variance is 3. So in this question, nothing is informed about the population standard deviation. So we do not know the population standard deviation. Hence, we proceed with the t-test. And it will be a one-tail test because here it is mentioned more than. Similarly, let us see one more example. So this is how you can make a decision on which test to choose. So an automated machine was designed to pack exactly 2 kgs of vanaspati. As the average weight was of 0.10 kg. Is the machine working properly? So here 1.94 kg is the sample mean and 0.010 kg is the sample standard deviation. Here also we do not know the population standard deviation. So should it be t-test? Yes, anyone, can you tell what test will be? Will it be t-test or should it be z-test? Response. So this will be again a Z test because the sample size is large. So this is how we choose the test. Now let us explore about regression. Regression is very much important. So we consider bivariate data, that is a data in two variables x and y. So what can we do? The first step is to visualize data. We plot a scatter plot. Visually, we can say that y increases with increasing x. We can say that both x and y move in the same direction. So this relationship between the variables is called correlation. Relationship between x and y seems to be linear. If we look at it, straight line relationship. So the degree of this linear relationship can be calculated using Curl-Pearson's correlation coefficient, which is given by this formula, covariance xy by sigma x, sigma y. And R lies between -1 and +1. If R is greater than 0, it means there is a positive correlation. R is less than 0, it means a negative correlation. So in negative correlation, x if X increases, Y will decrease and vice versa. So let us see what further analysis can we do after this visualizing part. After visualizing, further analysis may be do. We may explore the relationship between X and Y, the form of relationship. That is, we may define some equation. That is, we can express Y in terms of X and X in terms of Y. And use this relationship to draw some inference and also predict some future values. So this technique of obtaining statistical relationship of a bivariate data is called regression analysis. Let us see the procedure of a regression analysis. So this was our scatter straight line equation. And this quantity is called the error quantity because it is not a perfect positive straight line. If we draw a straight line here, then the data points lie we define as epsilon I, which is called the dependent variable or predicted variable, and X is called the independent variable or the explanatory variable. Now the aim, now there are some model assumptions. So the model assumptions are linearity, that is linear relationship between the independent and the dependent variable, independence of the data point, homoscedasticity, that is the errors should have a constant spread over all the values, normality of errors, that is we assume that the errors are normally distributed, the distribution we talked earlier, and there is no multi-collinearity. Multi-collinearity means the collinearity among all the variables, so there should not be high correlation between the variables. Now the next step is to obtain the best fitted model. So a model of best fit will be the one with minimal error. So the aim is to minimize the error epsilon equal to y minus beta naught plus beta 1x. So either we may, when for n variables, we may think of minimizing the sum of errors. But in general, minimizing the sum of errors is not possible because when we fit a mean line to this data, the sum of this error will be 0. So we cannot minimize. So we can think of some alternative, like we may take the absolute error, the modulus value of the error, and try to reduce this. So if we reduce the error modulus of this error, then what we get is called a least absolute regression. And when we try to reduce the square of the error, one more method may be square error. So we minimize the squared error, then this gives us least square regression, which is mainly used in machine learning techniques. So this concept of linear regression may be extended to multiple regression as well. That is regression where there is only one dependent variable, but independent variables. So x1, x2, xp are p independent variables, and y is the only dependent variable. So this is the linear equation for the multiple regression case. So in matrix form, we may define the model like this. And the same assumptions for this multiple linear regression is same as the simple linear model. And the procedure to find also is similar. So apart from this, there are many other types of regression. Some of these are polynomial regression or logistic regression, which is categorical data or having only two outcomes, 0 and 1. So we cannot go into details of this as well. So let us see some highlights of the regression techniques. A statistical method to model relationship between variables is called a regression technique, and it is used to predict continuous output. Like we can predict whether tomorrow there will be a rain or not. So based on some linear equation, regression equation. So, or what will be the future income or future growth, future population of a country? All this can be done using regression. Regression model generates a predictive equation which is used to estimate values of new input. So uses of regression in machine learning is forecasting, that is predicting, as I said, and risk management, estimating credit score or insurance risk. So it is highly used in risk management and anomaly detection data as well. So that's all for today. Thank you. Any question?
Hello.
Yeah, hello.
Thank you, madam. Yes. Thank you, madam. Am I audible?
Yes, sir. Thank you, sir.
Okay. On the behalf of all of us, I would like to express our gratitude to Dr. Renu Sharma from the University of Delhi for taking the time to share her invaluable insights with our students. So, during this whole discussion, some questions are there. So, I want to ask one by one the question to Dr. Dhirmi Sharma. Uh, so before that, I want to express my gratitude and thanks to Dr. Sharma for his valuable session on the basics of statistics of machine learning. This is totally informative and making all the important it's, different topic very easy to us. Her expertise in the subject is evident, and we are incredibly fortunate. We have an opportunity to learn from someone with such a profound knowledge and experience. So, thank you, madam,
Thank you so
again.
much, sir. Thank you, sir. Thank
Okay.
you all.
Now, I would like to ask some questions from the audience. They have asked some questions. I want to one by one. I want to ask you some questions.
Sure,
So,
sir.
my first question. One minute. Yes. One question is there. What kind of statistical analysis need to perform to validate the performance of any regression model in machine learning?
We can perform, there are many tests. So t-test is very much useful for performing in regression model as well. Or we can also, again, for multiple regression, we may obtain the r square, that is coefficient of determination, and predict on the model how well the model has fitted or how well the explanatory variables express the data.
Okay. Okay. And there is another question. That is that in a machine learning model, if you increase the model complexity to reduce bias, what will happen to the variance and why?
Yes, again, sir.
In a machine learning model, if you increase the model complexity to reduce bias, what will happen to the variance and why?
If bias is reduced,
Yes, yes, ma'am.
if bias is reduced, then the variance will increase.
Okay, ma'am. Okay, okay. And another question is there. That is, you have trained a machine learning model on a very small data set with a very few feature, and it performed extremely well on the training data but poorly on the test data. What would be the primary cause of this issue?
Yeah, maybe the model is not actually very well fitted to the means actually the model is of a poor fit. There may be many reasons. It is only fitting the training data. Means it became data specific. It is not very much acceptable in general. So we have to check whether means we can reduce it. May be overfitting also may be an issue. So we have to check with various process to remove the overfitting or maybe the underfitting. It won't be underfitting, definitely it will be a overfitting issue. So we have to remove the overfitting thing and then proceed.
Okay, ma'am. Ma'am, we have no other question from audience. So before I conclude, I would like to express my sincere and gratitude again to Dr. Ridley Sharma for her time and effort and dedication to making this session such a success. Her passion for the subject and willingness to engage with us made this event an enriching experience. One again, thank you, ma'am, to participate here. We hope to have a privileged session in near future again, and we want to
Yes.
learn more from you in near future. Thank you again, ma'am.
Thank you, sir. I also hope to have some more session with you. Thank
Okay,
you.
okay, ma'am. Thank you. Thank you.
Thank
Thank
you
you.
all.